Okay, so we're going to talk about objectives 4 and 5 from section 4.1. And objective 4 starts on the next slide, but just so you know, this is the data that we need in question in objective 4. And we had already done this during class yesterday. So if you remember, we found the R value here yesterday, and it was 0.7728. Okay, so we need this information coming up in objective 4 and objective 5. So objective 4 is to determine whether a linear relation exists between two variables. So we're going to do a test to see if a linear relation exists. So the first thing that we're going to do is determine the absolute value of the correlation coefficient. Again, correlation coefficient is the R value. And then we're going to find something called the critical value from table 2 and from appendix A for the given sample size. So we need to know how many data points that we have. And again, that table 2 will always be given to you. It's also in the back of your textbook. It's on the next slide. You're always going to have it. And here's the rule. If the absolute value of the correlation coefficient is greater than the critical value, then we say a linear relation exists between the two variables. Otherwise, if it's less than it, then there's no linear relation. Okay, so again, our R value was 0.7728 from that earlier problem. Okay, and again, if we went back and we counted the number of data values that were on that first slide, there were 12. So N is 12, R was 0.7728, and the absolute value of 0.7728 stays as 0.7728. So when I go to N equals 12 and I look, my critical value there is 0.576. So N is 12, your critical value is 0.576. So if we want to determine whether the linear relationship exists between the drill time to drill the 5 feet and depth at which drilling begins, and we're going to comment on the type of relationship that exists, we're going to use that information that we just had on the last slide. The correlation coefficient was 0.773 rounded to the nearest thousandth, and the critical value for N is 0.576. Since 0.773 is greater than 0.56, there is a positive linear relation time to drill that 5 feet. Okay, again, it's positive because R was positive. If R had started out as negative and you took the absolute value of it, there would still be a linear relationship, but if R was negative, then your linear relationship would be negative. That's the only little trick that there is there. Okay, and we're on to objective number 5. So we want to explain the difference between correlation and causation. Okay, so according to data obtained from the Statistical Abstract of the United States, the correlation between the percentage of female population with a bachelor's degree and percentage of births to unmarried mothers since 1990 is 0.940. Okay, does this mean that a higher percentage of females with bachelor's degrees causes a higher percentage of births to unmarried mothers? Certainly not. The correlation exists only because both percentages have been increasing since 1990. It is a relation that causes the high correlation. In general, time series data that is collected over time, may have high correlations because each variable is moving in a specific direction over time. Either they're both going up or down over time, or one is increasing while the other is decreasing over time. When data are observational, we cannot claim a causal relation exists between the two variables. So observational is the key there. Okay, we can only claim causality when the data are collected through a designed experiment. Okay. Another way that two variables can be related, even though there is not a causal relation, is through a lurking variable. And a lurking variable is related to both the explanatory and response variable. Okay, so for example, ice cream sales and crime rates have a high correlation. Does that mean local government should shut down all ice cream shops? No. The lurking variable is temperature. As air temperature rises, both ice cream sales and crime rates rise. Lurking variables in a bone mineral density study. So because colas tend to replace healthier beverages and colas contain caffeine and phosphoric acid, researchers Catherine Tucker and associates wanted to know whether cola consumption is associated with lower bone mineral density in women. The table lists the typical number of cans of cola consumed in a week and the femoral neck bone mineral density for a sample of 15 women. The data were collected through a prospective cohort study. The figure in the next slide is going to show the scatter diagram for that data. The correlation between the colas per week and bone mineral density is negative 0.806. Again, that's your R value. The critical value for the correlation with n equals 15 from table 2 in the appendix A is 0.514. So again, now all we're going to do is take the absolute value of your R value here. Okay, so because the absolute value of negative 0.806 is greater than 0.514, remember the absolute value is the distance that a number is from 0, so this would just become a positive 0.806. We conclude that a negative linear relation exists between the number of colas consumed and the bone mineral density. Again, it's negative because your R value was negative, and there is a linear relationship because this held true. So can the authors conclude that an increase in the number of colas consumed causes a decrease in bone mineral density? Identify some lurking variables in this study. So first, let's look at the scatter plot on the next slide, and then we'll answer that question. All right, so again, here's my scatter plot. And again, if I were to draw a line that best represented that data, again, you can see that it has a negative relationship from that picture. And now, in a prospective cohort study, data are collected on a group of subjects through questionnaires and surveys over time. Therefore, the data are observational. So the researchers cannot claim that increased cola consumption causes a decrease in bone mineral density. So what are some lurking variables in this study that can confound the results? Your body mass index, your height, whether you smoke or not can affect your bone density, your alcohol consumption, your calcium intake, whether it's natural or you're taking a supplement or lack thereof, and physical activity. Okay, the authors were careful to say that the increased cola consumption is associated with lower bone mineral density because of the potential lurking variables. They never stated that the increased cola consumption causes lower bone mineral density. And when we see each other again, we will start working on this. And that is all for 4-1.